Okay, the question will be like that. For example, okay, they say, okay, given a, sorry, okay, like for example, they will say part A. Okay, they will say find dy dx for y equal to x squared. Okay, can or not? So they will ask you to do that. Then part B. Okay, they will say find integrate by substituting u as x squared. So they will go question like that. Okay, they'll have a question like this kind of things. Okay, so then how you will do? You just do it accordingly, lah. So a dy over dx. Okay, I should put u lah instead of dy over dx. Okay, I put u here. Okay, find du over dx. Okay. Okay, so you find du over dx is equal to 2x. Okay, so then part B, you just follow what the question want you to do. Okay, so now they say by substituting u as x squared or x squared as u, x squared as u. Okay, so now I will just put 3x e x u. So that is how you're substituting x squared as u. So now, the moment you substitute x squared as u already, so you see here still dx, here still x. So you have to replace everything. So now from here, from part A, your du over 2x is equal to dx, am I right? So if I rearrange this, so isn't it, now I can do it as, so now I substitute this whole thing as this. So I put it in. Okay, so I have 3 over 2 integrate eu du. So 3 over 2 integrate e, you still get e, correct? Over 1, then plus c. Now you put back your u as x. That's it. So that is called integration by substitution. Are you okay? Hello? So it is possible they may ask you question like that. Possible. But they will lead you lah. So fraction also the same thing. Fraction also the same thing. So if I give you the fraction one, it will be the same as well. Like for example, I will say, for example, I give you like that. Given A, given u equal to x squared minus x. Okay, so find du over dx. Okay, so I will have 2x minus 1. Okay, so I am done with that. So then part B, they will say, hence integrate okay, got it? So what you need to do is, you see whatever they give is whatever have in part A, right? So you just write this as, can I write this as like that? Can, correct? So you see, this is your u. And from here, this is your du. So you just put here du. So the answer will be ln x squared minus 1 minus x plus c. Done. Because this is ln u plus c. It's not something that is difficult one. It's okay. Are you clear? Okay. Any other things? But when you talk about integration, yeah. Attendance cannot get the attendance. You try this number. 2FM62W. Okay. So any other question? But I still ask you to the more important one for integration, correct? Like integrate things like that. Still remember how to do the integration for this one? So I can do like that. Right? You change. So this is the one that I'm quite worried is. So you please write this one down. So that is how you change. So you get the answer x, take away 8 ln x plus 5 plus c. You get me? This kind of thing. So don't keep panic if this sort of question come up. And if you have question like that, so what to do? So all these are examples that you should write it down. Bottom can make it to complete square. Then you can know what to do, right? So for integration, what you need to remember is you need to simplify it. Okay, another thing about integration is the application about the area. Can you please go to 2017 paper? There's one talking about area, upper area, which area is bigger, which area is smaller, which value of the integration is positive and negative. That particular question, please refer. Or you can go to your textbook. You can go to your textbook. Your textbook also got such a question. Because for the past two years, correct, they didn't give much about the integration. Like for example, you go to your review set 5A, right? Okay, page 149. Have a look at how to explain question 3. The kind of question. Question 7. Okay, and where is it? And page 136, question 10, question 11. The one I explained a lot. Question 12, the kind of question, whereby you need to make some explanation. So can you please go through that? If you go to 2017, also got one question in that way. I'll try exam paper. Okay. Because for the past 2 years, they didn't really ask you to explain which is greater, which is smaller, and so on. They will ask you. They didn't ask you to choose. Second question. You want me to do this question? Is it okay? So this will be integrate x minus 1 to the power of negative 2 dx. So we use the simple rule, power plus 1 divide by their two number. One is the coefficient of x, one is the power. So you get negative 1 over x minus 1 plus c. Okay? Any more questions? If not, I stop recording. You may want to try this question. Okay. Given fx equal to 2 ln x plus 3 over x squared. Okay. A. Find the coordinates of its stationary point. Okay, and state the nature of the point. Okay, B, hence show that fx is less than or equal to e squared for all value for all x greater than 0. Okay. So the domain for this function is x is greater than or equal to 0. Okay, you may want to try. Give you some time to try. Then after that, I will do the explanation. Okay? Okay. To find the stationary point, first of all, you have to get the dy dx, okay? So we get our f prime x by using the quotient rule. So your u is 2 ln x plus 3. Okay. So your u prime will be 2, 1 over x. So it's 2 over x. Okay, your v is x squared. So your v prime is 2x. So you put into the quotient rule formula this way. So write down properly x squared times 2 over x. Take away, always this way first. Then 2 ln x plus 3 times 2x. Okay, the whole thing over x squared cube, a squared. So what you need to do is you simplify first. Then you factorize out the x. Okay, so you factorize out the x. So here left with 2, take away. Okay, be careful. Expand it. 2 times 2 is 4 ln x minus 2 times 3 is 6 divided by x to the power 4. So this one and this one simplify. Okay, so I have my f prime x equal to negative 4 ln x minus 4 divided by x cubed. So what you can do is you can factorize out the negative 4. Negative 4 ln x plus 1 divided by x cubed. Okay, so therefore, stationary point means f prime x equal to 0. So negative 4 ln x plus 1 over x cubed equal to 0. Cross. Negative 4 cannot be 0. So ln x plus 1 equal to 0. So ln x equal to negative 1. So x is equal to e to the power of negative 1, which is 1 over e. Okay, so that is the x coordinate. So the y coordinate will be f e to the power of negative 1. So just put it in 2 ln e to the power of negative 1 plus 3 over e to the power of negative 1 squared. So this one is negative 2 plus 3 over e to the power of negative 2. So the answer is e squared. So therefore, the coordinate is 1 over E and E squared. Okay, you want to know the nature, you must draw the sign diagram of f prime x. Since the domain for f prime x is x must be greater than 0, when you do your sign diagram, you better be careful. So this is your 1 over E. If you use your GC to draw the graph, you find that this graph go in this way. Am I right? Have anyone tried? Right? This is your fx graph. So this is your stationary point. Yeah. So when you look at the sign diagram, you know that this is, here is, yeah. What do you mean dotted? Because the domain x must be greater than 0, not part of 0. 0 is not part of the domain. That's why I must put dotted line. So go up, come down. Okay. So therefore, this is a local maximum. Okay, I want to prove that this is also the global maximum. You see or not? That is this part. So how to do that for part B? Okay, this is part B, very important. Part B, I must study the nature. I have only one stationary point. I want to know when it approach infinity, whether it go down or not, or whether it go up again. I don't know. So what I do is, I will say as x approaches infinity. So I will say what happened to fx. Okay, 2 ln x plus 3 will approach infinity also. But the infinity for x squared is much, much bigger. So this infinity is much, much bigger, right? Because it's x squared, infinity squared. So therefore, I will say that my fx will approach 0 because my fx is infinity. I will say this one I imagine like that, infinity divided by infinity squared. So it approaches 0. Are you clear? Okay. So from the other end, I will study as x approaches 0. You from this side, you approach 0. So I say from the right. Okay, as x approaches 0 from the right, that means the value of x, you can imagine the value of x is like that. This small. So what will happen to your ln? Okay, so your 2 ln x plus 3 will approach what? Negative infinity. Right or not? If ln of a number, you can put into your calculator, ln of any number that is less than 1. Okay, less than 1. The value is less than 0. Correct? So then your x squared will approach infinity also, approach 0 also, correct? So very small, divide by very, very small. So what will happen? Negative value. Okay, if you don't want, we just say it's less than 0. Okay, negative divide by very, very, very small positive value. So it will approach. So my fx which is 2 ln x plus 3 over x squared, will approach negative infinity. So therefore, this value of y is the maximum value, is also the global maximum. Therefore, I can prove that. So therefore, I can conclude. From here, I can conclude the maximum value of fx is e squared. So therefore, fx is less than or equal to e squared from here. From here. So this kind of things, will they ask? I don't know. I just make sure you. Okay, now I want to continue with here. If they want the point of inflection, they want you to show algebraically. That means you have to differentiate this again. That's the second derivative. Okay, so I'm going to show it to you. How am I going to differentiate this? You want to see, or you want to do it by yourself? You want me to show it to you? Okay. Yes or no? No, I won't show it. So if they ask for inflection point here, there's an inflection point here. They ask you to show algebraically, then you have to differentiate this. Should I differentiate it for you to see? Or you differentiate here? Yeah, here, this one. Should I? Okay, so I'm going to show it to you. So my f prime x is -4 ln x plus 1 over x cubed. Okay, so when I do, I will take my u as ln x plus 1 and my v as x cubed. U prime 1 over x, v prime 3x squared. Okay, so put into there. Just put the -4 outside. Okay, just put the -4 outside. Okay, so we sub in the formula this way first. Please always remember 1 over x cubed, take away ln x, ln x plus 1, bracket it up, 3x squared. The whole thing divided by x cubed to the power of 2. Okay, simplify. So we got -4. When we simplify this becomes square, and we have the common factor x squared. So we take out the x squared. Okay, open bracket. So here become 1, take away 3 ln x plus 1, then divide by x to the power of 3 times 2 is 6. Yeah, so you simplify. So this one you have to be very careful. So it will be -4, the x squared cancel this one power 4. Okay, so it will be, here is 1 minus 3 ln x minus 3. So it will be -3 ln x minus 2 over x to the power 4. So this one equal to 0. So I have 3 ln x minus 2 equal to 0. So my ln x equal to -2 over 3. So my x is equal to e to the power -2 over 3. Okay, so differentiate this is something that is quite quite have to be very careful lah. Okay, because it involves ln and that one, so you have to write it carefully. So this is the coordinate x of the inflection point. So the y coordinate, you have to go back to your that formula. Yeah, the beginning one. That is 2 ln x plus 3 over x squared. Okay. 2, you see, when I substitute, correct? 2 ln x is this one. Okay, negative 2 over 3 plus what? She still cannot remember. Plus 3. Okay, plus 3. Then over x squared. So e to the power of negative 2 over 3 power of 2. Then you simplify. Okay. So this will be the inflection point. So this will be the place whereby it decreasing at the fastest rate. Inflection point decreasing at the fastest rate. This graph is look like the search function like that. Okay. Did you try to use your graphic calculator and get the answer? And the f prime x graph, will look something like that. Do you have that? This is your f prime x graph. Okay. Okay, any further question? Next class is tomorrow. You want me to explain 2021? Okay, I record down 221. 2021 Northern Hemisphere question 9. Okay. Okay, I will do that. I will do that. Yeah. It's quite a long question, is it? Definitely, question 9 is in booklet 2, sure, long. Okay, so I will do that during the next lesson. Next lesson, that means next week. Ethan, are you from the other class? Class 2, is it, Ethan?
Yeah.
Yeah, okay, so tomorrow, I will explain. Okay, so class, so please do your revision, whatever is it. Okay, thank you, class.
Thank you, Miss.
Thank you, Miss.
Yeah.